Okay, in this video, we continue our discussion on conditional statements. We now discuss example number 4. It says, write the negation of the following conditional statements. What then by negation of conditional statement? If you recall from the handout I uploaded, the negation of the conditional statement P implies Q can be obtained by first using the conjunctive form of on P implies Q, which is negation of P or Q. Then after that, you apply the De Morgan's on this one, right, which is negation of the negation of P, which is P, and then or will become and, okay, and then negation of Q. In other words, the negation of a conditional statement is of this form. Okay, so for letter A, your P is I receive my salary, and your Q is I will go on vacation. And the negation of this is P, which is I receive my salary, and negation of your Q, which is I will not go on vacation. Okay. Number 2, if you come early, you will not miss the exam. Again, you come early is your P, and you will not miss the exam is your Q. So the negation of this statement is P, which is you come early, and okay, and negation of your Q, which is you will, so we remove now the not, no? Miss the exam. Now, letter C is an interesting problem because the consequent is actually a compound statement. But following again the form for the negation, we write the P, which is absolute value of x equal to 2. And, okay, the negation of your Q. Now, your Q is x equals to or x equal to negative 2. That means that we, using the De Morgan's, we negate this, which is x is not equal to 2. And then or will become and negation of this, which is x is not equal to negative 2. Okay, so this is the negation. Number 5. This time, we're going to talk about converse, inverse, and contrapositive of the conditional statement. Again, to recall what do you mean by converse, inverse, and contrapositive. Okay, the converse is if this is your if-then form, the converse is the consequent becomes your antecedent, and then the antecedent becomes your consequent. What about the inverse? The inverse is when you negate P, which is your antecedent, and then negate Q, which is your consequent. And then the contrapositive is the negation of your Q or your consequent is your antecedent this time, implies negation of your antecedent, which is P. Okay. So following this, what is the converse of this statement? Okay, the converse is when you make this as your antecedent and this as your consequent. So that means that it will be if I cannot get to class, then my car is in the repair shop. Okay. What about the inverse? The inverse is you get the negation of your antecedent, which is if my car is not, okay, is not in the repair shop, then the negation of your consequence, which is I can get to class. Okay. Contrapositive is when the negation of your Q becomes your antecedent. So that means that we negate the consequent here. If I can get to class, then the negation of your antecedent, which is my car is not, okay, in the repair shop. Next example number 5. This time we're going to determine the truth value of biconditional statement. Biconditional statement, because the connective used here is if and only if. In symbol, that is P double arrow Q, no? We call this P if and only if Q. Again, to review, what is the truth table for the biconditional statement? We say that P if and only if Q is true if P and Q have the same truth values. So that's why we have true for P if and only if Q, if P and Q are both true. But if they have different truth values, your biconditional is false. Since we have both truth values are the same, no? The truth values are the same, so we have true for P if and only if Q. Okay. For letter A, what is the truth value of this? Let's first assume that this is true. Okay, suppose this is true. If this is true, that means that what are the possible values for x that makes this true? There are only two possible values of x now that makes this true. That's either 5 or negative 5, because absolute value of 5 is 5 and absolute value of negative 5 is 5. But question is this true when this is true? Let's see. If x is equal to 5, then this is true. But what if your x is negative 5? Then this is false, right? In other words, you have a case where the truth value of your P and Q are different. Therefore, this is false. Again, if and only if Q is indicates that this is a biconditional statement. Okay, assuming that this is true, is this true? Yeah, we can easily verify that this is also true now. If this is false, we can easily verify also that this is false. Therefore, this is true. Okay. What about this? If this is true, meaning x should be 3 or negative 3, right? Okay. No other values will make this true except when x is 3 or negative 3. Now, notice that it uses the phrase necessary and sufficient. That's also the same as if and only if. Okay? So this is actually a biconditional statement. Now, if this is true, meaning your x is 3 or negative 3, is this true? Yes, this is actually true. Because when you square 3, you have 9. When you square negative 3, also have 9. So, can we say that this is true? Actually, yes. Because if you assume that this is false, meaning x is not equal to 3 or negative 3, you can check that this is also false. So therefore, this statement is true.